Hey guys. The last time that we talked, or y'all watched my face, we were talking about GMOs and kind of continuing the discussion about the Green Revolution and how agriculture is a lot different now than it was a couple hundred years ago whenever we were just doing subsistence farming. Um, However, agriculture does not just include like vegetables, it also includes farming of meat and farming of fish. So, before we get into all of the different things we're going to talk about today, I want to just, again remind you that because of the law of tens, because of how energy is passed up amongst trophic levels, it is always going to be more energy efficient to eat lower on the food chain. Um, and again, I think we talked in class about how like this unit is kind of being preachy about being a vegetarian, honestly. Today is not going to get any better. But if you eat down here on this first trophic level, you're getting more energy than if you eat up here on this third trophic level, which is up here is where usually humans occupy. Um, so it's more energy efficient for you to eat vegetables than it is for you to eat meat. Okay, so that's always going to kind of be hanging in the background of, you know, the pros and cons of agribusiness. Is it's more efficient, not only energy wise, like energy that goes into my body wise, but it's also more efficient like economically because you know if we're looking at these things right here, I can eat one carrot and get X amount of energy, or I can eat one hamburger. That cow had to eat 10 carrots to give me the same amount of energy. So that's always going to kind of be a concern of ours. Excuse me. So today we're talking about CAFOs, or concentrated animal feeding operations. Basically, what we're talking about is high density animal farming, trying to put as many animals into the smallest structure or smallest field that you can manage. You have these really high density. This is an example of an indoor structure. Sometimes they will be outdoor. Again, the goal here is to get maximum output of the product. So they do this a lot with pigs. They do this a lot with chickens, especially here in Arkansas. We have a ton of these chicken CAFOs. And you need to make sure that you know what a CAFO is and then what some pros and cons to it are. Um, so one of the good things about farming in this way is it is very cost efficient. Okay, you are making sure that there's not any waste. It's land efficient. So usually, if a happy chicken wants, you know, I don't know, 5 square feet of land to itself, you can stick them all in here, and that greatly minimizes the cost of the land that you have to purchase to make these chickens happy. You're not really going for happiness, you're going for maximum efficiency. You also get improved feeding efficiency, so you can make sure that each individual animal, well, not necessarily 100% make sure, but this is the closest you can come to making sure that every single animal gets the exact same amount of food to maximize the profit of having these animals. Again, you're never going to have 100% of that because like you're always going to have stronger chickens here that are going to push away the weaker ones and you know all that, but this is the closest you can get to making sure that every single animal is treated identically. And then this part's really sad. But you get the highest food to energy ratio, so you don't give these animals a lot of space to move around, which means that they eat food and less of it is used to move their own body. So if we go back to looking at these pigs here, there's like 15 pigs in one of these little things right here. There's not a lot of place for them to move around. So that means that when they eat this food, they're putting it on as fat or muscle, probably fat mostly, let's be honest, and not burning that running around and moving around and playing and stuff. So it's really kind of sad. But if you don't give them a lot of space to move around, they're not going to use the energy in the food that they eat. So you actually will get more than 10% of that. We're shooting for higher percentages as you move up. So, um, obviously there are a lot of cons to doing animals this way, namely that it's just really, really sad. Every vegetarian or vegan that I know or like is on the internet that I've read about, this is why they switch over to not eating meat is because this is like really sad. Especially like this last point right here, this is very, very sad to me. So, it's kind of hard to stomach treating animals this way. even though, like I know that a lot of the chicken at the supermarket comes from these kinds of situations. So again, we talked about like, voting or picking with your dollar. It's more expensive to get the free range chicken that they were nice to, but that means that the chicken didn't have to grow up in these kind of situations. So, another issue that you get into with these CAFOs is you have to deal with density dependent factors. If you're sticking this many animals into a enclosed structure, you're going to have to deal with a lot of disease, a lot of waste management, um, a lot of health issues, things like that. And so a lot of times what they will do is they will supplement these animals with antibiotics and vitamins and um, they used to do growth hormones. They don't do growth hormones in chickens anymore, but they still do in cows and pigs. Um, I know that that's like a big like joke is like the growth hormones in chicken and all that. Not in chicken anymore, but in cows and pigs for sure. But you have to supplement these animals to kind of deal with these density dependent issues, the problems of sticking this many of them into an area. And then our book doesn't actually talk about it, but another significant problem with these CAFOs is the CO2, methane, and nitrogen production of them and pollution of them. So when you have this many animals concentrated in one area, their waste products, like their poops and their farts and their dead bodies and stuff like that, is going to produce a significant amount of gases, carbons and methanes and nitrogens and nitrates that are going to, pollute the air. I used to have a statistic memorized, I don't anymore, but it was like a significant amount of climate change, like not non negligible climate change, comes from cow farms because of like the methane of the waste and the poop and stuff like that. So there's a lot of gas pollution. That's not even taking into consideration the machinery and the fossil fuels it takes to run these kinds of things. So, speaking of waste, there's this, I think it's kind of funny and at the same time horrible. There's this issue there's this issue raised with how to deal with that waste. And one of the solutions that farmers have is to create a manure lagoon. So, I want to do a little bit of math here to just kind of parse out how much manure we're actually talking about. So, if an individual animal or an individual cow produces 53 liters of manure each day, and the average CAFO for cows holds 900 cattle, how much manure is produced each day? I'd like for you to pause the video and do that math, and I'll give you just a few seconds to do that. So hopefully it's not hard math, hopefully you typed that out and found that it will produce almost 50,000 liters of manure a day. Okay, so 47,700. You got to have somewhere to put that, especially if you are trying to put them all in the same area like this. You can't just, ignore all of that manure that is laying on the ground. You have to do something with it. You have to collect it and move it and put it somewhere. So, a manure lagoon, which is basically just a pond that they put the manure in, typically will hold about 30 days worth of manure production. So what does our minimum capacity have to be on that lagoon? And again, I'll give you a few minutes or a few seconds to think that over. You plug that in your calculator. All right, so when I put that in my calculator, every manure lagoon, if we're dealing with averages, needs to be able to hold 1,431,000 liters of manure a month. Okay. I did some, calculation on that because I was curious because that number doesn't really mean much to me, and I found that it's roughly about 70% the size of a Olympic-sized swimming pool. Olympic-sized swimming pools, again, are a lot larger than the pool at Prairie Grove. So that's a lot of poop. This is what it looks like in real life, where they just like have a giant swimming pool that they are dumping poop in, and it's got water in it too. And the goal with these things is to help it break down, and it releases a ton of methanes and a ton of carbon dioxide and a ton of nitrates as bacteria and microorganisms kind of churn through and eat this poop. And then what they have to do is they have to spread that somewhere, and they can't just leave it there because next month we have a whole new thing of poop to put in there. So what they will do with them is they have these machines called manure spreaders, which look like this right here. So your average manure spreader can spread 20,000 liters of liquid per trip. Okay, so that's how much this particular, manure spreader can spread. You attach it to the back of your tractor, you drive it around a field, like maybe like a cornfield or, just like some field, to try and spread out and fertilize that field. And that's a really great use of this manure, putting it back and letting it be a fertilizer. But we get into another question here. So if we can hold 20,000 liters of liquid, how many trips is it going to take for us to remove that month's worth of manure? So I'll give you just a second to stick that one in your calculator. And if you put that in your calculator, you're going to get 71.5 trips. That's a lot of trips. Okay. There are people who work at farms that their whole job is literally to spread manure. They drive one of these trucks all day, every day, like that's all they do, because it's a constant thing that they have to be dealing with. So if we look at the average tractor, and again, without being really, really specific here, if we look at the average tractor, roughly top speed is going to be about 20 miles an hour. Okay, these guys are not going to be going 20 miles an hour when they're spreading the manure, so let's rough in that they're going to be going 10 miles an hour. Okay, so they'll be half speed. They're probably going to be going slower than that. I saw a lot of averages said that they would go about 5 miles an hour when they're actually doing farm work, but especially if they're like trying to get an even spread, because what'll happen is this, the tractor will drive, and this is all the manure, and there's like a turbine right here that like flings the manure into the field. So they're probably not going super fast because they're wanting to get like, an even coating of the manure. But let's say they're going 10 miles an hour. Okay, on average, a tractor gets 5 miles per gallon of diesel fuel, which means that if we're driving at 10 miles an hour and we work for 1 hour, we're going to use 2 gallons of fuel. Okay, and that's not terrible, but when you take into consideration that it's diesel, and every gallon of diesel burned produces 22 pounds of carbon dioxide. Okay, so I'm not sure how many trips or how many hours it would take to take 75 or 71.5 trips back and forth from these manure ponds out into the fields, but I do know that every hour that they are, moving back and forth, they are producing 44 pounds of carbon dioxide from the back of that tractor. So that is not a negligible thing right there, the amount of, fossil fuels that goes into upkeeping these things. And then if you are blowing all this manure up into the air, you're aerosolizing a lot of the particles in this. Okay? Now, if it was just cow poop, that would be one thing. However, these animals get fed lots of supplements, lots of vitamins, lots of antibiotics. There has to be preservatives in a lot of the foods. So a lot of that stuff will get aerosolized as well. And that is a issue, especially with chickens. Okay, so one of the preservatives in chickens is arsenic in the chicken feed, and it travels through the chicken's body and gets in the chicken poop, and when they redistribute that poop, it aerosolizes it and causes things like cancer clusters, testicular cancer clusters in, casually, just our town. So, when I come back to school, hit me up and we can talk more about this. I don't really want to get into it. I'm getting close on time here, but the pollution that comes, the air pollution that comes from, these kinds of farms, that's an issue. So, one more thing that I want to talk about with these guys is bioaccumulation. Again, they're putting antibiotics, they're putting, vitamins, things like that into these animals to help them deal with living in such confined quarters, and that accumulates up the food chain, which means that, if I eat chicken every day for a month, I am eating a lot of antibiotics that are in that chicken meat that was fed to that chicken. So, not cool. But, okay, so that is it on the high density animal farming. I'm going to stop talking.